Here's a really quick and dirty presentation of average value of a function. It's not the only way to do this, and it's certainly not the most rigorous. But let's just start off with a physical question. I'm painting a wall, and here's what the wall looks like. It's got a curvy top, and it is 5 feet wide. It's got a flat bottom and straight sides, but it's got a curvy top. And suppose somebody's told me that the average, on average, the average height of the wall is equal to 3 feet. Then how much paint do I need? Or in other words, what's the area of the wall? It's 5 feet wide, and on average, it's 3 feet high. And I'm not trying to trick you. Think about it for a sec. The area is just going to be 5 times 3 is 15 square feet. If you believe that, then you understand what I'm going to say about average value and integrals. That's really it. It's that the area of a shape like this with straight sides, straight bottom, but any kind of top, is just the width times the average height. That might sound familiar because that's how we describe the formula for the area of a trapezoid, the width times the average height. And in fact, it's true for any shape that has these straight sides. It's just the width times the average height. So, again, I'm not trying to prove anything rigorously, but if you believe that statement, then you're going to believe, hopefully, the next thing. Okay, so suppose I have a wall. Okay, let's say, just to be different, let's say it's 7 feet wide. And suppose I just reverse it. Somebody has painted it. They figured out how much paint they needed. In other words, they figured out the area is 28 square feet. And they say, oh, on average, can you tell me how high this thing is? Well, the area is supposed to be the width times the average height. And so the average height is just going to be that 28 divided by the width, which is 4 feet. So why is that useful? I think the previous one is feels a little bit more natural because people can say, oh, I can imagine certainly calculating the width with just a tape measure and then getting some sort of approximation of the average height, and let's not worry about exactly how right now, and then calculating the area. But when would I be in this situation? I would be in this situation if it's really easy to calculate areas of shapes, and we are exactly in that situation because we have the fundamental theorem of calculus. So let's look at the average height of the graph of, say, y equals 1 plus x squared over the interval 1 to 3. So what does that look like? From 1 to 3, that starts out at 2 and goes up pretty high, I guess up to like 10. Not quite to scale. So it's like this. So this is a funky wall with a width of 2. Notice that's 3 minus 1 equals 2. That's going to come in. Okay. And I know how to calculate the area of this thing, so I can then use that to calculate the average height. Okay. So what we usually do is we think of as average value of the function, but it's just the average height of the graph. It's the same thing. Okay. And so the area, we'll calculate that first, is just the integral from 1 to 3 of 1 plus x squared dx, which is x plus x cubed over 3, antiderivative, from 1 to 3, which is going to be some weird fraction. 3 plus, oh, that's not too bad, 9, minus 1 plus a third, or 4 thirds. So that's 12, or 36 thirds. So 32 thirds. So that's the area of this. To get the average value, you just divide by the width. Just average is just the area divided by the width. And so the average value of f on this interval is just going to be 1/2 of 32 over 3, 16/3. Let's see if that makes sense. One of the things you should check about an average is it should be between the min and the max. If you know the min and the max, which often you can either know or estimate, that gives you a useful check. This is 5.33-ish, is 5.3 repeating. That's definitely between 2 and 10, and it's not ridiculously close to either of them. And so that's a pretty good check. That's probably the right answer. At least I hope it's the right answer, unless I made an arithmetic mistake. So the upshot is that we've got a formula for the average value of f on an interval AB is you take the area, which seems, I think, like a more sophisticated concept, but it's where the fundamental theorem applies, and then you divide by the width of the interval. That's just b minus a. And so that's our formula. So the nice thing is it's absolutely trivial to calculate these guys if you know how to calculate intervals. It's not anything more complicated, and I really don't know why they save it for the back of Chapter 6. That's why I tend to do it right now. We've got enough technology for evaluating integrals that we can do a lot of them. Not everyone. Nobody can do everyone. But for whichever ones you can do, you can also calculate average values. Okay. And then we'll say a little bit more as well about some ideas around average value. But that's the formula. And it's just that the area of a wall is the width times the average height.